Hey everyone, welcome back to the channel. I hope you guys are doing really well. So we will see today's daily challenge on Leetcode and we will also try to solve it together. So let's see the problem statement at first. So kth lexicographical string of all the happy strings of length n. Okay, so you are given the definition of a happy string at first, that the string consists of only characters from the set A, B and C. So it cannot consist of any other alphabet, and all its adjacent characters must be different. So si not equals to si plus 1 for all values of I from 1 to len minus 1. Okay, so you see that A, B, C all are, the adjacent characters are all different in this string also, in this string also, and in this string also. So they are called to be a happy string, but also they consist of characters of only A, B, C, nothing more than that. But if you see, these are also characters containing A, B, C, but they have some repeated characters. So there should not be any adjacent repeated characters to be called a happy string. Okay. And given two integers n and k, consider a list of all happy strings of length n sorted in lexicographical order. Okay. So you need to return this kth string from this list. Or if you might need to return an empty string if there are less than happy strings. Okay, happy strings of length n. You can see, look at these examples. Uh, of length 1, there can be 3 happy strings, right? Since the string length is only 1, you can include only 1 character and there are total of 3 characters. So at max, you can have only 3 values for the happy strings, okay? A, B and C. So all contains happy strings of length 1, and the third character they are asking, okay? Kth character you need to return. So the third character is C. So that is what they have returned over here, okay? Now if you see, for k equals to 4, you can return an empty string because there are only 3 happy strings of length 1. So yeah, that's the thing. And yeah, for n equals to 3, there are 12 different happy strings if you see. If you arrange them in lexicographical order, they will be something like this. And if you return the ninth string, you will get this one, okay, CAB. Well, that's what you need to return in your answer, okay. So, and if you say it's only 10 and K it's 100, okay. So let's see, let's try to understand how, if there is any pattern in this problem. So, we will try to solve for particular n values. Okay, so for n equals to 1, what can be the happy string? As we saw, I am writing in lexicographical order only A, B, and C. Okay, so there can be only A, B, C, and nothing else. So how many strings we got? We got only 3 strings. Okay, for n equals to 2, try to arrange in lexicographical order and tell me what will be the happy string. They must contain only A and A, B, C only. So A, and the smallest lexicographical order is AB. You could have written A. This is lexicographically smaller than this, but this is not allowed only as a happy string. Okay. So the first string will be something like this. The second string will be AC. Trying to write in the lexicographical order again. So trying to take B, it can be BA. BB again, it cannot be possible since it's repeating. So you will write BC next. Okay. CA you can write, and again you can write for CB. So how many strings you got? You got 6 strings over here. Okay. So for n equals to 3, how many strings you will get? You might notice that you will get the first 2 string which will look something like this, A, B, A and A, B, C. Sort of that, and next one will be A and B done. So A, C, A, and let's say A, C, B, something like that, and so on. So how many exactly strings will be there? So if you notice one thing, you are able to append 2 characters. So if you take A and try to derive some strings by appending elements to the end of it, okay. So what will you get? You get B. If you append B, you get AB. If you append C, you get AC. Okay. Similarly, for B, if you append A, C, instead of itself, you can append both of them. Okay. So instead of B, you can append both A and C to this. Okay. So similarly, you can derive 2 string from each string. Okay. So one observation, the particular observation which happens is that you can tell that uh, derive 2 strings. Okay, you can call them child strings from each string in previous level. Okay, in previous level. So yeah, I am calling this nothing but level. So can you tell me again, can you tell me for n equals to 3, how many such will be there? So for this AB, you see, you derive two strings again. You add this A and add this C. For this AC, again, you derive two strings. So for this, all these three, six strings, you will be able to derive two for each of them. So 6 into 2, 12. Okay. And so on. Again, 12 into 2, 24 will be for n equals to 4. So I hope you do understand the pattern. And yeah, these I am calling the levels. This is the level 1, level 2. So from the previous level, you have only two of them. Okay. And if you notice how many elements are there at a particular level, at a particular n, how many strings are there, it's quite obvious. At first, it starts with 3, then it goes 3 into 2, then it goes 3 into 2 into 2, so 3 into 2 square, it goes 3 into 2 cube. So it's very simple. For n, it will be 3 into 2 to the power n minus 1. Okay, this is the number of happy string. I hope this is very clear. This is simple only to understand. Okay, not much difficult. Okay, so mm, first thing what you can easily check is that if your k exceeds, if you want something, so let's say you gave uh, n equals to 3, which will make a total of 12 happy strings, but you are asking, let's say, k equal to 14. So you need to return an empty string because 14 string does not even exist. So how will you return that? So that thing you can easily write out. Okay. So one obvious thing is that if a happens to be greater than 3 multiplied by 1 left shift of n minus 1. So 1 left shift of n minus 1 is nothing but 2 to the power n minus 1. I hope you know this. And if you simply return an empty string for this, okay. I hope that is very simple. And in order to solve this problem, one obvious brute force is that what you can do. So brute force solution is that generate all strings. Okay, generate all strings and store them in a list. Now easily you can do that using backtracking, right? Because for every string you can just go through and you have two choices to append that apart from the last element of the string. You have two choices to append. Okay, so I hope you can easily generate by backtracking, generate all strings and store in list. Okay, and then after doing that, what you will do, select the kth one. You can easily do that by selecting just the index. Okay, select the kth one. So yeah, you have done by brute force. And uh, is also n equals to 10, right? So for n equals to 10, if you try to put this value over here, you will get 2 into 10 to the 3 into 2 to the power 9, which is 3 into 512, which is of the order of 1.5k. Okay, so this is very much acceptable. This many strings you can easily store and select the kth one. Okay, so even brute force will work here, but definitely we will talk of some optimized solution. Yeah, if you do the brute force solution, it will be accepted for this problem. Okay, but yeah, let's explore that how exactly can we mm, do for this. Okay, so let's see. I hope you did understand the brute force solution and you should be able to uh, code this on your own also. I will show you the optimized one. So yeah, uh, let's see. Uh, for showing you the optimized one, let's take a good example at first and first try to let's say complete this string. Okay, and see some deeper patterns lying within this. Okay, so B will be there, BAC will be there, BCA will be there, B will be there. Okay, and again, what you can write, uh, CAB, CAC, you can also write. You can also write CBA, you can also write CBC. Okay, so this will be the 12th string. I hope this is the 12th string. Okay, So let's say in the question it is given that find the 11th string and here n is 3. You need to do this without generating all the string. Okay, without generating all the string, you need to do this, and your answer will be CBA. Okay, I hope you do understand this is the 11th string. So how will you do it? How will you do this? So in order to do this, you see, you you try to backtrack, okay, and see from where this string comes from. Now you see that this actually comes from the previous level, uh, from CB, right? From CB, this is its first child. Okay, so CB gives the child to CBA and CBC. Okay, this is the child, these two are the child. Okay, so I want to see that, hey, look at one thing. I know that if it's the first child, I will append A to this. If it's the second child, I will append C to this. Okay. So I want to know whether it is the first child or not, or the second child. That I can easily understand. So if it's an odd number, you see 11 is an odd number. That is why it is the first child. If it was an even number like this, the 12 string, it would be have been the second child. Okay. This much I hope it's easily understandable. And I want also to know the number which is deriving from the previous level. Okay, so I want to know that where is this CB lying from this. So I know that CB is lying from the sixth string, right? But I want to calculate that from just CBA. Okay. So you see that the 11th string over here, you can just do 11 plus 1 by 2. Okay, you will get 6. Now 12 also, if you try to do 12 plus 1 by 2, that is also 6. So this is a valid formula. You can just sort of quickly do it and understand that it's nothing but if you try to do divided by 2 and the seal value of that. Okay, so 6, if you try, you see that both 11th and the 12th have come from the sixth string. Again, this sixth string, if you try to divide it by 2, you get 3, and you do realize that you get this from the first level third element. Okay, you get the first level third element, and again this is an even position. So it is the second child. Okay, so it is the second child. So what I can do, now, it's very simple. You see, it's very simple. Whenever you will get a k, whenever you will get a k, you try to reduce it all the back to n minus 1 level. So you see, there were n levels, right? For this, I am in the level 3, and this is 2 levels above me. I want to go to the first level and see which was my first character and which all characters I am appending. I can easily see which characters I am appending by just telling that whether my first child or the second child. Okay, only that one. So that information also I will store. But yeah, I will need to go 2 levels up. 2 levels up I need to go. So for nth level, I need to go n minus 1 levels up. Okay. So since you are going n minus 1 levels up from k, you need to divide n minus 1 times. So what is the division which I am exactly talking about? So let's say you are told to get the 11th string. So what you will do, you will say that, hey, this is an odd number. So I will do plus 1 divided by 2 and get 6. Hey, this is an even number. So I will do simply divided by 2 and get 6. So n minus 1, that is 2 times divisions I do, and I stop over here. Now you see that the element which I get is 3. Now third element is nothing but C. It's very obvious. So it will return C. And you see, one thing is that this is plus 1 by 2. This is the first child of that. Okay. And this is, since this is an even number, this is the second child of that, only divided by 2. So C tells that after returning, you give me the second child. Okay. So since 3 returns and gives C, this 6 will return and give the second child. So C will have two childs. One child will be CA and another child will be CB. So the second child which will be returned will be CB. Okay. Again, CB will tell me I have again two child, CBA, CBC. You want the first child. Okay, you want the first child. So I will return to the answer. I will return CBA. So your final answer will be CBA. So what all things you need to store? You need to store the order of the child number. Okay, so whether it is the first child or the second child, and you need also to have a while loop where you will keep dividing, or for loop also will do, whatever, where n minus 1 number of times you will keep dividing, okay, and you will also keep storing whether my first child or second child or not. And you can store these things in a vector. So let's say I store this 1 and 2 in a vector, but now from C I saw that I got 3, right? So my first element in the answer is C. Now I need to append some things into the answer, so I need to process that in reverse order. So first I will process the second child, then I will process the first child. Okay, so you can just reverse the vector 2 comma 1, and you see that C needs okay, C, you have C, then you are processing this, you need the second child of C, so you go to CB, then you are processing this, you need the second child of CB, first child of CB, so you get CBA. That's the answer. Okay, and I hope you can easily do this in a for loop. So let's try to code this out. Let's try to code this out. This will be very simple and very optimal also. This one. Okay, so we will see we have a vector into egg over here. We have div, let's say div, which is the number of times I want to divide it. Okay, so what is the number of times? It is nothing but n minus 1. I need to divide it by n minus 1 times. So while div minus minus, you can give, okay, like this. So now what you can do, if k is odd, k and 1 means if k is an odd number, what I will do? What I will do to k if it's odd? I will just add 1 and divide by 2. I just now told you, right? And while doing this, I will also ensure that this is the first child. So I will insert a 1 into the vector. Okay, I'm creating this vector over here now. So and else, if k is even, what you can do is that you can just simply divide k by equals to 2, vec dot pushback and 2. Okay, so we have it. This gives you whether the first child or second child. Now, definitely, you need to process this vector in reverse order. So you do vector dot begin and vector dot end. So yeah, I hope you do understand for this. And uh, yeah, now you can simply paste in your answer some things, right? So have the string answer as an empty string. Uh, Now, if k is, let's say, 1, okay, k is 1, you append your answer to have an a, else if k is C, it can be 1, 2, or 3 only, right? So if it's 3, you append your answer to. So I hope you do understand. 11, you reduce this to 3, so you understand that this is nothing but the C, okay? The first element is C. So that's what, else if k is 3, just append your answer to have C, okay? Again, after doing this, what you can do, you can go through all the elements in the vector list. Okay, so I will use an auto operator for that. Auto X, I will just go through all the elements of vector. What I will do now is try to append elements into this vector, into this answer, okay, by seeing the last element, whatever is the last element. Now, if x is equals to 1, it means that the first child you need to append, okay, the first child you need to append. But let's store a character ch, which is nothing but the last character in answer, okay. So if the character happens out to be a, what is the first child? What is the first child? If the last character is a, the first child will be b, it will not be c, okay. Else if the last character is b, the first child will be a again, right? Else, I hope you do understand, right? If it is C, the first child will be again A. And else, either x will be 1 or x will be 2, right? So for x equal to 2, you can also have something very similar. If this is A, your second child will be C. If this is B, your second child will be C. If this is C, your second child will be B. I hope you do understand that how these things are happening. So if your last element is B, apart from B, you can have everything as append everything as the last element. So apart from B, you can append A or C in lexicographical order. This is your first child. This is your second child. Okay, A is the one. A is smaller than C lexicographically, so that's your first child. So for C, you get to append A as your first child, B as your second child. Okay. For A, you append B as your first child, C as your second child, and so on. Okay. I hope this much is very simple and not at all confusing, and simply return answer after this. So let's try to sum it and see if it works for all the cases. Or we did some mistakes. So yeah, we did do some mistakes. Uh, let's see what is that. Let's see. While div minus minus vector dot pushback k, we have if k is greater than this, return an empty string. Uh, div is that n minus 1 levels I need to push up. While div minus minus, what I do, I see that if k is odd, you need to divide this and tell that this is my first element. At the end, you will change this vector, and if k is 1, you append an a to your answer, right? So as we were considering the case for 11, you see b is appended to the answer. Why is it? C should be appended, as we saw. So k is 11. It first checks that if k is odd, it does k plus 1 by 2. So it turns it to 6. Okay. And in the next iteration, k equal to k by 2. So 6 by 2, it will be 3. So 3, and 3 will give the answer to be. Okay, so you see this is always getting true, k equals to 2. That is why it will be equal to 2. You need to check our criteria, right? I hope you know these things, and if you try to submit it, you get an 100% acceptance because it's a really optimal solution. It's a simple linear solution, right? Uh, yeah, and apart from not even backtracking solution. So yeah, I do hope this solution was very much understandable. So yeah, that's all for this video. I will meet you in the next video. If you have any doubt, you can definitely ask me in the comment section. Till then.